Hello everyone, welcome to this video. Today in this video we will be talking about the second part of y'all's 14th lesson in y'all's grade 7 science textbook, and under this topic we are going to talk about thermometers, how we use them, about the scales and about the clinical thermometer. Now without any delay, let us start off with the lesson. Now again, to remind y'all, if y'all have not watched the previous part, I'd recommend y'all watch that before y'all come to this, and the link to it is down in the description below. Furthermore, this is y'all's textbook and I have just highlighted some important things. If y'all want to jot down some important things, I suggest y'all can make y'all's own notes by just including whatever I have highlighted or some additional things that I will be telling here. So this is basically going to be sort of like a pre-training for y'all before y'all go to upper grades, because not always y'all will be given a very keen, accurate or a very detailed note. So it's better for y'all to learn how to prepare y'all's own notes. So think of this as a way to prepare yourselves. Anyway, coming back to the lesson, we are going to talk about thermometers. And here, as you can see in this diagram, we are going to start off this lesson by making our own bottled thermometer. So what we are going to do is we are going to basically take a small glass bottle like this. We are going to fill it with some colored water. You can take some water, add some coloring, whatever color you like, and fill the bottle. You are going to insert a stopper. This blue color part over here, you call it a stopper. You are going to insert a stopper and we are going to fix a tube of a pen. We are also going to take one of these strips of papers, jot down a suitable scale. So you can copy the same scale that you will get in these thermometers and you can simply fix it here. And then we are going to place this whole thing in a water bath. This is a water bath, because this is a beaker and into the beaker we have filled water, and this is what we call as a water bath. Now once this is done, we can put a little cold water, hot water, in order to make the temperature hot or low. And then what we can do is we are going to take one of these stands and we are going to fix a thermometer to it and dip it also in the water along with this bottle thermometer. We are going to then take our measurements. We are going to see what's happening to the thermometer when we change the temperature by putting hot and cold water into this water bath. Then you will notice that this red color mark is changing. The more hot the water is, the more it rises. The more cold it is, the more it drops. Okay, so you all can try this out at home if you all have a thermometer and some of these instruments. Now normally this thermometer, this liquid inside, is filled with mercury, and therefore if it's filled with mercury we call it a mercury thermometer. At the same time you can use alcohol for it. So normally we have colored alcohol and it's normally red in color. So those are called alcohol thermometers. Okay. Yeah. And this was a model of a water bottle thermometer that we made. And like I had said earlier, now we are going to talk about scales of thermometers. Now this is very important for not only your current grade but for higher studies as well. Now there are several scales present in thermometers. Some scales are Celsius. The most commonly found one is Celsius scale. The other one is Farenheit, and internationally you will get Kelvin. So these are the scales that we can use to measure temperature, which is also present in most of these thermometers. Now here you can see both an alcohol thermometer and a mercury thermometer. This red color one is the alcohol thermometer, and this other one, this silver colored one, is the mercury thermometer. So mercury is silver in color and therefore this is mercury thermometer, and this is the alcohol thermometer. And mercury is really a dangerous substance. We shouldn't handle it. We shouldn't break this open and like take it to our hands. It can cause certain harm to us, and it's really a dangerous substance, so we must handle it with care. So it's better to take some help from an adult when you handle these. So when you come back to the scales, here you can see the temperature scales, and over here you can see the unit. So Celsius, the unit is this, degree Celsius. Fahrenheit is this. Kelvin is this, capital K. Now the international standard unit, the unit that is accepted all throughout the world, which is also called the SI unit, is Kelvin. This is the internationally accepted one. Okay, we must remember that. Now there are different units to measure the temperature, but there is a equivalence between the principal temperature scales, and here you can see them. So it's not compulsory for you all to remember this Fahrenheit and Kelvin scales, but if you all could, it's better. Nevertheless, you all will be learning how to convert Celsius into Fahrenheit and also into Kelvin in y'all's grade 10 O level. But for the moment, the most important thing y'all should remember is this column. This Celsius column, everyone should remember it, because it's important not only now but also for your entire life. Now, for one thing that you all should know is boiling point of water is 100 degrees Celsius. This is very important. Water boils at 100 degrees Celsius. Freezing point of water, water turns into ice at 0 degrees Celsius. The body temperature, the mean average body temperature of us humans is 36.9 degrees Celsius. So now these three are really important and we must memorize them. Okay, so now talking about boiling point and freezing point, now we are going to see a little more about all these boiling points and freezing points. So first and foremost, we are going to talk about the melting point and the boiling point. So we're going to start it off by doing a practical, and here this is the aim. As you can see, this is the aim. We're going to find out the constant temperature at which ice changes into water. So to do this, all that we are going to do is we are going to take some ice, a glass funnel, and a beaker and a thermometer. You're going to place the beaker like this on a table. You're going to take the glass funnel and keep it on the beaker like this. Put some ice cubes, place the thermometer like this, and let the ice turn to water and melt. Then you are going to observe this reading. Over here you can see that if you observe the thermometer, you will see a scale. Then you are going to take the reading. So here you will be able to notice that the scale over here is 0 degrees Celsius. That means the ice is going to melt at 0 degrees Celsius. So over here you can see the observation, and over here this is the conclusion. Then we can conclude that the constant temperature at which ice melts is what we call as melting point of ice. Okay, so ice is solid, it's absorbing heat and then it's turning into water, that is the liquid. Okay, so the ice, if this is an ice block, it's cold, so it's going to take in heat, it's absorbing heat and then it's turning into this liquid. Okay, next up we are going to talk about this melting point a little bit more in depth. So the constant temperature at which solid substances changes into its liquid state is what we call as melting point of a substance. So like I had said earlier, how this solid turned into a liquid is what we call as melting point. The temperature at which a solid turns to a liquid. So when water is cooled, ice is formed. When we remove heat, now when we give heat to the solid, it turns into a liquid. So here heat is being provided or heat is absorbed. So if heat is removed or released, it's going to be the reverse of this. So if you remove heat from water, you're going to get ice. Okay, so water, as we had said earlier, it solidifies or it turns to ice at 0 degrees Celsius. So the freezing point of water is 0 degrees Celsius. Now here in this table you can see several melting points of substances. The most important one out of all is ice, that is 0 degrees Celsius. Besides that, you have paraffin wax at 60 degrees, lead at 317, iron at 1539. But the most important one is ice. Okay. Now with that, we are moving on to the boiling points. So over here, the constant temperature at which liquid substances turns into gas is what we call as boiling points. And here this is the AM. So we are going to find out the boiling points of water. For that, we are going to do this activity 14.4. What you're going to do is you're going to take a boiling tube, and then you're going to put some water into it, place a thermometer in it, fix it to a stand and heat it over a Bunsen burner. Now since this is a boiling tube, you can directly boil it. You don't need to use a water bath. The reason is, when we use a water bath, we use a water bath to prevent these beakers from exploding or various things that are inside these beakers from splashing out. So since this is a boiling tube designed to withstand heat, you can use it. Now when you do this practical, you can heat it and until it boils. You will wait for some time until it boils. Then you will notice this gas is evolving and bubbling. You will notice so many observations. Okay, so then you will notice that this temperature at which this gas is evolved and bubbling occurs is exactly 100 degrees Celsius. So that is what we observe here. Then we can conclude that there is an exact temperature for the boiling of water. So water, which is a liquid, is absorbing more heat to turn into steam, which is a gas. Okay, so just to summarize again, ice, which is a solid, is the symbol for solid. We take in heat. This triangle represents heat, and then it becomes water, liquid. More heat is taken in and this water turns to steam, which is a gas. Okay, so this part is what we call as melting point, melting, and this part is boiling. Okay, we should keep that in our mind. So the constant temperature at which a liquid substance changes into a gaseous state is called as boiling point of that substance. Now if you look at this table over here, you can see some important boiling points of substances. Alcohol, 77 degrees Celsius at 1 atmospheric pressure. So now this ATM is called atmospheric pressure. Okay, atmospheric pressure and temperature and stuff, it's not a really important thing for y'all, not even for y'all's O level normally, but it's really important for A level. But y'all just remember, boiling point of alcohol is 77 degrees Celsius. Paraffin wax 370. Water, it's very important. Water, you should memorize it. Like I said earlier, 100. Lead 1744. Iron 2900. And after this, over here you can see this part which is called for extra knowledge. Now this for extra knowledge part is not really that important, because normally they do not question you all about it a lot. There are instances where school papers may question you all about this, but most of the time not every paper questions you all about it, so you all can just go through it and read it, but it's not really that important. But if you consider it, it's really important for your future studies and stuff, but for y'all's current grade it's not that important. It is important but not that important. Okay, now we are going to see how to use a thermometer correctly. First and foremost, you should know that you should keep a thermometer vertical and not horizontal. Now vertical is this: we stand vertically and we sleep horizontally. So this way you should hold the thermometer vertically and not horizontally. And then when we are taking the readings of the thermometer, we should keep the thermometer at our eye level. So if this is the eye, we should keep the thermometer, like you can see in this figure, at the level of our eye. So you can hold the thermometer like this, and here your eye should be somewhere like this. Then you should make sure that the eye is kept correctly in line with the mercury column, like you can see over here. So you can see the eye is kept properly on the proper line. It's not above, it's not below, so you can see the exact reading. So if you don't keep your eye, let's say you keep the eye somewhere here, then you might see something else like this. If you keep the eye somewhere here, you can see some other thing like this. It's not the correct reading. You should keep it like this. It should be perpendicular to this column of mercury or alcohol. Okay, so that is really important. That's how you handle a thermometer. Now, keeping all of that in mind, we are going to do this 14.5 and activity 4.6 to see how to take the readings correctly. So here you can get the aim. Now what you're going to need for this is a beaker, some water, a thermometer and a laboratory stand. So here what you're going to do is you're going to place this, you're going to connect the thermometer into a stand, place the thermometer in this water bath, and it should be exactly in the middle of the water bath, and you should clamp it vertically like you can see it over here. Then you're going to keep this eye exactly in line with this mercury column and take the readings. Next thing, we are just going to need a thermometer. You're going to hold the thermometer vertically and you're going to keep your eye in line with the column and observe and take the readings. Then this is the next activity, 14.7. So here what happens is you're going to take a beaker, fill it with some soil which you get in the garden, school garden, house garden, anywhere, some soil. You're going to dip the bulb of the thermometer into the soil, and then you can get the readings. So normally there is a special thermometer used for these type of practicals. You call it a soil thermometer. It is a thermometer used to measure the temperature of a soil. Okay, so that we must understand. Now just like that, there is this thermometer which we as humans use to measure our own temperatures, and that is what we call as the clinical thermometer. Now over here you can see a clinical thermometer. One very important thing you should remember about this is how to label a diagram like this. So you must understand this middle long tube that you can see inside the thermometer is what we call as the capillary tube. This bend is what we call as the fine bend. This top part that pops out of this thermometer is what we call the bulb. Here we get the scale in degrees Celsius. Okay, so this is what we can do. So the normal body temperature of the humans is this, like it was 36.9, but when you round it off it's 37. Okay, so now there are two specific features of this clinical thermometer. First thing is this fine bend. It's a special feature. Second thing is that this temperature ranges from 35 to 43 degrees Celsius. This is the second special feature. Now keeping that in mind, we are moving on to how do we use these clinical thermometers to measure the temperature properly. Now what you're going to do is, this bulb of these clinical thermometers, you're going to wash it with some antiseptic solution. So you can use some alcohol, a bit of some clean water, something to destroy the microorganisms. So antiseptic solutions are solutions that can be used to destroy microorganisms. So you use some special like alcohol to remove these microorganisms. So cleaning it with that solution, and then normally we place this bulb under our tongue. So especially if you are an adult, you simply open your mouth, and if this is the mouth, okay, you raise your tongue, you put the bulb in, and then you simply close it up. You wait for some time, for about 2 minutes, and like this you can see over here how this child is waiting for 2 minutes and how he has put the thermometer into his mouth under the tongue. And we are going to take the readings accurately as we hold the thermometer vertically straight, keep the eye in line with the mercury column. We are going to take it like that. So we must follow all correct procedures as we do it. So let's say you're just a small baby and it's hard for you to wait in one place while keeping the thermometer inside your tongue for 2 minutes. In that case, we can simply keep the thermometer under the baby's armpits for a few minutes and we can get it. Now in these clinical thermometers, I had mentioned about this fine bend. So the reason for this fine bend is that the fine bend prevents mercury column from rising up or falling down before the measurement is taken. So once mercury goes through the column, that bend, the fine bend, it prevents mercury from falling back into the bulb, nor from rising up, because it's there to help us get the readings more accurately. And then they also say that this thermometer should be shaken well to send the mercury column down the bend before it is used for the next time, because the mercury column prevents the mercury from going up or down. We must shake it well, put all the mercury into the bulb before we take the next reading. So the body temperature of a healthy person is 36.9 degrees Celsius or 98.4 degrees Fahrenheit. The new type of thermometers are invented for measuring body temperature accurately. These digital thermometers, you can get the exact volume without any parallax error or anything, because you just have to put it under the tongue or under the armpit and then you get the temperature reading. So that's it for today. Hope you all understood the lesson, enjoyed it. If you all did, don't forget to click on the like button, subscribe to my channel if you all are new, and share my content with your friends. So get ready for part 3. Until next time, bye.